Great. Good afternoon, everybody. Praveen and I are painfully aware that we're the only thing standing between you and ice cream. So we'll try to make this as engaging and interesting as possible. Thank you for coming, and really, it's great to see everyone here. My name is Ben Speed. I'm the manager of the Application Services team within InterSystems. Application Services is an in-house app dev team within InterSystems that we use Iris to solve our own business problems, make our own line of business applications, including some of the ones that some people in this room might use, like the evaluation service, also our SSO services that are used for WRC, iService, developer community, et cetera. And so we get to do day in and day out the types of things that our customers get to do in using Iris to solve their problems and to create interesting solutions. And I'll let Praveen introduce himself.
Hi, my name is Praveen. I work on Ben's team, working on internal applications, including our single sign-on and including our Git source control project, which some of you might have used as well.
All right, so the goal of the session today is going to be two parts. We are going to start out talking about just some dev best practices in general, and then going into some of the details of that. This is all the theory side. This is the drier bit. We got it. Make sure you've got a good foundation before Praveen gets to do the really interesting part and jump into an actual demo of what this can look like in practice using Iris and all open source tools that would be available to you to get started on with right away. So first of all, development best practices. What you see here, and actually I'm going to stand over here so I can reference that and not keep looking over my shoulder. But what you see here is basically it's like a ladder. Right? There's a progression of best practices that you as a developer can attain towards as you move from authoring code to being able to control that code, to being able to do automated testing, right? Because if it's not automated, it's not going to happen. Automated installations, continuous integration, orchestrating all of these pieces, and then to automate provisioning. And wherever you are on this ladder, there's always some interesting bits just beyond and some value to be attained just beyond. So what I'm going to be focusing on in the first half is really talking about controlling your code. And then Praveen's actually going to show bits of other steps of the ladder as we go up. So just out of curiosity, how many people in this room have a source control solution that they are completely happy with? Okay, all right, and that's why you're here, which is great. So hopefully we'll be able to provide you with some vision, some answers to what some options are available to you on top of InterSystems products. So let's get into that theory. So the first thing I'm going to define is a shared development instance. Now this is pretty common in our user base, and basically because of the complexity of the configuration and integrations, it makes it difficult to automatically create private instances of the deployment for each developer to work on, especially if you're talking about health share instances or more complex integration engine instances. And so historically, we've had the situation where many developers would connect to a shared environment, a shared dev environment, where they can make their changes and then there'd be some process to move those changes forward. Now, this is likely to result in collisions because different developers might be working on the same file, the same configuration item, and you can really only have one person touching it at a time, right? You don't want to have bleed-in of multiple developers' work, into that same file because you could have stuff accidentally promoted that shouldn't be promoted. But this is, again, the historical way many of our customers have worked with developing against Iris Data Platform and the various applications built on top of it, Health Share, Track Care, Iris for Health, et cetera. So we had shared development instance. A private development instance is the scenario where each developer actually has their own sandbox to work in. This is the more common way in industry to work. There's more upfront work required because you have to have a combination of documentation, automation to make it very easy to make development instances. But then once you have that plumbing in place, once you have done that instrumentation, that means that now you have a new developer in the team, or developer starts working on a new project, they need a clean environment for, you can spin up a development environment. They can just work in that isolated sandbox. Now, this requires source control to be done effectively because otherwise there's no way to have multiple environments that are being changed be kept in sync, right? And so this sort of presupposes source control in order to prevent lost source. but it allows each developer to work in their own sandbox. They're not going to interfere with each other. And if they're working on the same file at the same time, they'll have to just take care of that at commit time or at merge time when they're checking into a main branch and merging with the work that their colleagues have done. So we had shared development environment, we had private development environment. Now we're going to talk about server-side source control hooks. Now again, this is the historical way to use source control management software on InterSystems products. On server-side source control hooks, the actual hooks that fire off source control events like checkout or check-in or export or block a user from editing something happen within the instance itself, or on the Iris server. And this is the way that InterSystems Studio worked for years. Again, there were no controls in Studio itself, but it relied on the server it was connecting to provide those controls via server-side source control hooks. So the hooks always fired on the server, that is the machine that the database lived, and the source control files would then be managed typically on the file system, although some solutions like George James, they will manage it within the .dats themselves. But again, the idea is that the management happens at the location of the instance itself. This allows multiple developers to work in a shared development instance because the hooks manage item concurrency. If I'm editing something, Praveen opens his IDE and connects to it, he's told, you can't edit this right now, Ben has it checked out. Example hooks, server-side hooks, have been available on the InterSystems Open Exchange, although these are not supported by SCM vendors. They're contributions from InterSystems or our customers or partners. And the hooks are all configured within a namespace. So you could have an instance, multiple namespaces, multiple sets of hooks or configurations. Nothing needs to be configured within the IDE, VS Code or Studio. You just connect and you're automatically sort of within the guardrails of how you're intended to work in that environment. So we have server-side source control hooks. The more common way, and continued. We also call these today embedded source control hooks. And the reason for that is there are many types of source that we actually allow you to edit through the system management portal, right? So there are things like interoperability productions, DTL, BPL, the record mapper, lookup tables, rules, all these things, InterSystems BI, we let you edit them through the management portal, and we actually enforce the server-side or embedded hooks within those UIs. So the same thing that's controlling your IDE is also controlling those pages. So only one person can check out the lookup table at a time, or it'll tell you if somebody else is editing it. So this applies to those control configurations in the SMP, and only on those items whose UIs have been wired for source control. So again, we'll talk a little bit more about embedded source control later, but just understand that because of the way Iris operates, not everything is as simple as just managing a file in the file system when it comes to your configuration and your source. All right, so server-side source control hooks. Now we're going to talk about client-side source control hooks. This is the approach where the source control management, or SCM, that follows industry norms and typical development practices. So if you're working with C, if you're working with Java, if you're working with Python, you're actually working with physical files. They're typically on your machine where your IDE is, and the IDE is managing the hooks to control those files on your file system. So it's managing it directly without Iris being in the middle. And again, that's where you are actually composing your development creation from these flat files as the main point of what you're editing. VS Code manipulates the files in the local file system, not the database server, and the manipulation interacts directly with the hooks. Source files are pushed to an InterSystems. So if you're working with object scripts, source files are then pushed to an instance from the developer's file system, so they can be saved and compiled and tested on that remote instance, but there's no source control there. The source control is local. And so VS Code supports a wide variety of client-side hooks out of the box. The hooks are broadly used, and they're supported by the various vendors. But each developer has to configure their own local client-side hooks to manage their synchronization within their private development instance. So again, we have the server-side hooks as compared to the client-side hooks. Let's put it all together. All right, so initially we talked about shared development instances on the bottom, also private development instances, the server-side source control, and the client-side source control. So historically, Studio only provided two ways of working, okay? It was always going to be server-side source control, but you could have a local instance of Iris that you were using the source control hooks on. But again, those hooks were connected to the database itself, not to the Studio IDE, or a remote instance that multiple developers could work on. Now, with the advent of VS Code, with the introduction of VS Code as our IDE, now we could finally support private client-side hooks, all right? But also, VS Code works just as well using the InterSystems file system, or ISFS, in the private server-side method or the shared server-side method, because VS Code connecting to your database instance is going to have to be in those same guardrails and follow the same rules as the Studio connecting. You want to avoid shared development instances with client-side source control. I'll go into that a little more in detail, but I just want you to note that there's one spot on this matrix that's going to, in all likelihood, end up giving you a lot of pain and frustration. So you want to try to avoid that when you're picking a strategy. So what exactly is the issue with client-side hooks in a shared dev instance? All right, so we've got two developers here, both with client-side source control configured, so they've got their own copy of the files, but they're all connecting to a shared dev instance to do their work. So one makes a change to B, pushes it out to the environment in order to do their testing, do their compilation, and now two makes a change to D, pushes it out to the environment to do their testing. And now one starts to work with F, pushes changes to F out, and two, again, because the source is local, they don't have the changes from F. They're going to have to, from developer one, they're going to have to do some sort of reconciliation, decide whose version do I want to keep. They might not even notice, because they haven't pushed yet, that F has been edited, so they make their own changes, but then they're told, well, you can't push it because one has done the change. And so then they might need to force it to override, because I need to test my changes. I got to push them there. Developer one's still thinking their changes might be there. They go to test, and all of a sudden their changes are gone. So what we see is an inconsistency with what one would expect, developer one might expect, or what developer two might expect. And that's going to end up causing frustration, because the shared development instance is always going to be in an indeterminate state with regard to either the source set that developer one is working with or the source set that developer two is working with. So that's why this is an approach that can lead to a lot of frustration. If you need to have a shared dev instance, a much better approach is to use the server-side source control hooks, because that acts as the control in order to ensure that the changes are consistent and there's only one workspace that's being represented. So in that same scenario, one would edit B, B would get pushed to the file system, but it's still in a checked out state to 1. 2 would edit D, D gets exported to the file system, it's still in a checked out state to 2. 1 edits F, that gets pushed. 2 is not able to edit F. So 2 knows right up front, wait a second, 1 has F checked out, they can see the results of F's change. Now 1 has to commit their changes from the workspace into the depot, and that frees up F for developer 2 to start making changes. Now they can actually see the changes that were previously made and committed, and they can layer their changes on top of them. So that allows for much better communication and cooperation between the various developers on the shared namespace. It still results in some collisions, right? Because there's the single checkout, there's only one person can edit at a time, but if you understand that that's an acceptable constraint within that environment, it's certainly workable. All right, mixed mode, a private development instance. So this is new, especially with a lot of modern UI stacks, where you can actually edit some things with server-side and some things with client-side hooks, as long as you have that set up properly. So it takes the power of the embedded source control hooks, along with the ease of the client hooks for full stack work. So it could be like a local container, a locally controlled instance, but it's the same developer working, again, in a private namespace. Client-side hooks here are actually used for editing UI code, like Angular code, and relies on the built-in hooks inside of VS Code. And they're used to edit all the artifacts for UI dev in a local file in the file system, and then they can use ngserve in order to serve it up and do their testing, etc. The server-side hooks can then be used for editing their object strip classes or other embedded config items in the SMP, so they're able to capture things like changes to a production or changes to lookup table or changes to mapping rules, etc. And that will still be writing, though, to the same local file system and allow you to have both areas of work in the same depot, under the same control, same view in the file system. It takes different routes to get there. The other mixed mode is a shared development instance, where, and my team does this all the time. We've got a shared Iris-based instance. It's got the data. It has the REST services that it's hosting up, but a developer wants to make a change to a UI. And so they have a local workspace where they do their UI code, D, E, and F, but A, B, and C, the server side, the REST services, the persistent classes, those are sitting on the shared server using embedded or shared server-side source control hooks, and that's where they make those changes. And they're able to have their locally compiled UI point to the APIs on the shared server for doing their testing against the data, against the services. But again, they're able to use everything built into VS Code for client dev, for UI, use those tools to the greatest extent, but still rely on the server-side source control hooks for the object script pieces, which is, again, the sweet spot for those hooks. So again, this is another means of doing sort of a mixed mode and if you want to talk about your specific situations, grab Praveen or myself or Tim afterwards, and we will be happy to talk about helping you guys navigate to a strategy that works. So once you've got source control in place, then you could have a whole bunch of models mixed together in hybrid. You could have a shared namespace that a couple developers connect to, and that workspace gets committed to source control. But then you could also have a developer, that has a private instance where they're doing their own work, and again, they'll be able to merge in at the source control level when they're making changes. And this gives you the opportunity to mix and match client-side, server-side. As long as you avoid that shared development client-side hooks, you can use all of the other pieces in a way that makes the most sense for your team. All right, so we're going to talk about getting onto the source control train. It's important to know that if you're starting to use source control or start changing how you're using source control, the format, et cetera, the tools, you need to have a known starting point, because you have to take everything that you already have written and get that into source control as your initialization, because without a proper baseline, reverting or diffing changes may not be possible, right? Because you're actually there's nothing that you're making on top of. So if you add something to source control rather than having a baseline, then if you revert that change, the revert of an add is a delete, and you don't want that, right? So you need to get everything that's in your namespace into your source workspace as a starting point, and then make incremental changes on top of it. So there are several tools for baselining. Praveen's going to demonstrate the get source control option. There's a baseline export method in %studio source control ISC. There's a project on GitHub called SCUDL. You can make your own based on your own configuration. But I just want to highlight the fact you need to start with a baseline, and then you go on from there. And then one other consideration to think about when it comes to server-side source control hooks, they can play a really important role in non-development instances. Now, everybody knows if you've got an Iris instance, you've got a developer with sufficient privileges, it could be the stage environment, it can be the live environment. But again, if you have a developer with privileges, they can fire up Studio, they can fire up VS Code, they can connect to that environment and potentially start making changes, right? That's a bad thing. We actually had it where developers accidentally attached to the wrong environment and made changes they didn't intend to make. So we do everything we can to make it clear this is the wrong environment, and I'm seeing some nodding. Sounds like we're not the only one who's had that experience. But you can also use server-side source control hooks to implement namespace-wide locking, right? And so because everything that's going through that IDE is actually firing the source control hooks. And so in our hooks, we actually have the ability to set a single global and lock all source in the entire namespace from any IDE, because the source control hooks will enforce that. All right, so unless all IDE access is blocked in non-dev environments, server-side hooks can control the ability to edit code, locking all source with a system-wide or namespace-wide flag, auditing who turns off the namespace source lock in a break the glass scenario. Sometimes you need to get on there to debug, right? But it should be an intentional thing to turn off the lock and then and audit that, who has done that. Tracking who makes emergency or debug changes, allowing emergency or debug changes to be diffable against the original source, again, because there's hooks involved. And also, as mentioned before, don't forget about the benefits of protecting your SMP managed config configuration with a lock. So that being said, there's a lock. There's a picture of a lock now. Great. I'm going to turn it over to Praveen.
All right, so at this point, I want to walk you through a practical example of using Git to source control code in an Iris application. So first off, we're using Git. Git is just one version control system out of many good options, but it is the most widely used one among software developers, to the extent that if you tell somebody that you're using version control, they'll probably assume you mean Git. Besides that, there's a bunch of different source code hosting services that are built on top of Git. So for example, GitHub, GitLab. In this example, we're going to be using GitHub as a Git remote repository. And it also includes some automation for defining continuous integration pipelines. So second, we're going to be using Git source control. Git source control is an open source project, primarily maintained by our team at InterSystems, not really a supported InterSystems product, but an open source project. This is what provides an embedded source control experience for Git using whatever means you're using to write code. So the management portal of VS Code Studio. It's those server-side source control hooks that Ben was talking about earlier. This gives you support for multi-user development environments. Git by itself will not give you support for that. It also gives you a basic web UI for certain Git operations. And that's something you'll want to use on a shared development environment. And it even has some support for deployment using Git to pull code into an instance. So where are we starting? Where are we ending? My starting point here in this demo is way at the bottom of this ladder. We just have an instance where we're authoring code using VS Code Studio, the system management portal. And we want to move up a few steps on this ladder. So most importantly, we're going to be source controlling our code using Git. We're also going to be running some automated tests using the %unit test package in ObjectScript. And we're even going to have some continuous integration using GitHub Actions, a basic pipeline. I'm going to be kind of glossing over automating installation and automating provision. So you remember this quadrant from before? We're going to be in the lower left-hand corner of it. We're starting with a shared development environment. We're going to stick with that because it's easiest for now. But we want to add source control, so we're going to be using our server-side source control hooks. Some more details about the end state that we want here. Our changes are going to originate in a development namespace. Developers are going to make changes there, commit them to a main branch in Git. From that main branch, they'll get pushed to our main branch in our GitHub repository. And we'll have a GitHub action, our CI pipeline, that automatically runs a build and test in a container based on those pushes. When we're ready to deploy our code, we're going to merge those changes from our main branch to a production branch. And from our production branch, we're going to deploy them into our production instance, our namespace, that users are actually seeing. All right. So now I'm going to sit down so I can control our video. And all right. So starting off, I'm going to show we have a VS Code connection that's showing off our development and production environments. In our production environment, you'll see we have some code in a demo package with some classes that defines our application. So you'll see there's a persistent class, there's a production, there's a business rule. There's even a unit test that somebody wrote once. But this is probably never getting run because there's nothing automatically running the test. So who knows if it still passes. We also have our development namespace, which for now is just pretty much empty. It's just a fresh interop-enabled namespace. So we have our application. I want to set it up with source control. And my first step to do that is going to be to create a repository on our Git remote, which is GitHub. I'm going to choose a default name for it, make it private so only I and my team can edit it, and initialize it with a README file, just so it has something in there to start. You'll see that was really quick. Now we have a remote repository for our application on GitHub. Now that we have that, we want to set up our namespaces to actually talk to that remote. And I'm starting from very scratch. I'm going to start by installing the InterSystems package manager. And you'll see if you go to the package manager GitHub repository, there's a one line you can just copy, paste, run on your environment. We're going to use the package manager once we have it installed to install Git source control, which you'll remember is the server-side source control hooks. And that's a very simple command using zpm install. Here I'm just going to show that I already have that run by doing a list command. All right, so the second step after installing it is we need to run a command to configure it with some of our source control settings. So I'm going to run this command in terminal and feed it some of our settings. These first two settings are pretty important. So the local git repo root folder. This is the directory on our file system where our source code is going to live. And that's going to be a local git repository. The second one here is a path to a private key file. This is a private key that's going to authenticate our Iris instance with GitHub so we can pull and push code from that GitHub. You'll notice if it doesn't exist, Git source control will actually create that key file for us, which is nice. A lot of these other settings, I'm just going to go with the default. Some user-specific settings where I'll put in my username, email, etc. At this point, we see it created a public key for us and output the public key for us. Very handy. I want to configure GitHub to allow that public key. The way to do that in GitHub is to go to my repository settings and add a deploy key. Here I can copy in that public key and give it write access. That means I can originate code on my Iris instance and push it to GitHub. Now I have that deploy key set up, I can actually clone a repository. And it'll use that key to authenticate myself. Remember, this is a private repository, so not everybody has access. I'm just going to copy in the URL for that, using SSH importantly. And I see it cloned that repository locally. While we're at it, I'm going to go through the same process on our development namespace. Most of our settings are going to be the same, except for our local git repo root folder. That's going to be using a different git repo, a different directory on our file system. But you'll see we're cloning the same remote URL. All right. Now that we have both of those configured, you'll see that Git source control has created Git repositories on our local file system. I'm going to go through a kind of annoying little step here, which is fixing the ownership on these repositories so that Iris has the access it needs to make changes there. And since this is Windows, I'll be diving through an endless array of menus to do that. I'm just going to change the ownership to system, which happens to be the operating user of the Iris instance. And this might be different for your own Iris instances. Maybe it's on Unix and you won't have to worry about it as much, or you'll have to worry about it in a different way. I kept this in for honesty. It's only going to take a minute or so. And once this is set up correctly, I'll presumably never have to do it again, at least on this machine. All right. So we fixed the ownership. Now we have local Git repositories. However, those repositories are empty. You'll remember Ben earlier talked about baselining your code. And now I'll show you how to do that using Git source control. We have this method in the Git source control API called baseline export. I'm going to pass it a commit message and also the name of our origin. This is the remote repository. By default, it's called origin. Just a note, this baseline export feature is not yet released, but it'll be included in our next release of Git source control, which will hopefully be in a couple weeks. So when we run this method, we'll see it's adding all of our classes in our namespace and routines, etc., to source control, and it's actually creating a commit and pushing it to GitHub. And I'll see now we have our classes and routines and tests all on GitHub. So that's great. We have our production environment baselined, but you'll notice from our diagram before, our production environment doesn't want to be tracking main. We want a separate production branch. I'm going to go ahead and create that based on main, and I'm going to repoint our production namespace to use that branch. So now I'm going to show you the web UI built into Git source control, because that's an easy way to do that. I'm just going to refresh our list of remote branches. See, we have the prod branch we just created, and I'm going to check it out. Once that's done, our production namespace is going to be tracking our production branch in Git, in the local Git repository. All right, so our production is all set. Now we want to set up our development environment. Remember that namespace was pretty much totally empty. What we want to do is load it with all of the code from our baseline. And to do that, I called another method on our Git source control API that just pulls. This pull method does a git pull, so it gets all the changes from our remote into our local repository. And it'll actually see exactly what has changed and load them as needed into the namespace. You can see it's importing and compiling these classes and routines. Now if I go back to VS Code, I'll see our development namespace actually has all the code that we want to be editing. All right, one more thing we want to do. Well, there's a lot of things we want to do here. But I want to add that continuous integration pipeline. I'm not going to spend too much time on this, but the way I'm going to do that is by creating a GitHub action definition. And this is a YAML file with a list of steps that we want to be running. So one thing I want to stress here is that a lot of the work of setting up continuous integration is automatically configuring an environment, deploying all code to it, running your tests, etc. And the absolute easiest way to do that for an ObjectScript application is to use the InterSystems package manager. You can create a file that defines all of your resources associated with your application, and that makes it really easy to build and test your application in this context. There are some other presentations you might have gone to about that. Here I'm going to take a really naive approach, which is just loading our code into the instance and then running unit tests. That's missing a lot, for example, actually reporting the results in a good way, but it's good enough, I'd say, for a 15-minute demo. So now we have that GitHub action definition. I want to walk you through the process of actually making a change as a developer would. I'm going to edit a class in our development namespace, make a code change. This is something a customer requested or a user requested, that donuts not only have a flavor, but they also have a size. Once I've made that change, I'm ready to commit it. And I'm going to do that through the Git web UI. So you'll see in our working copy here, we have that workflow we added earlier, and we even have this change that we made, and we can view the diff for it and see exactly what we changed. I'm going to commit this with an informative message, adding GitHub workflow and making a sample change to donut. I'll commit it to our local Git repository. And now I'm ready to push it to the remote, which is GitHub. So I'll just click this button to push the branch to the remote. All right, let's see that in GitHub. If I refresh and switch back to the main branch, I'll see we have that latest commit. And because we added that action, we'll see a little dot that says some action is pending. We can actually go here and see what's happening. So here, GitHub is actually provisioning a container for us. It's pulling an Iris Community Edition into that container, and it's building all of our code, and it's running our unit tests. And we see they all passed. So that unit test is actually providing us some value now, because it runs automatically whenever we push code. So our action is passed. I'm going to say our change is good. It's automatically testing. And I'm ready to actually go live with our change. And remember, the way to do that is to merge all of our changes from our main branch to our production branch. I'm going to use GitHub to create a pull request to do that. GitHub pull requests are great because I can document them, I can have my other developers review them, and I can view all of those actions running our tests. So I'll see I created this pull request to go live with this change, and it's actually running our action again. I'm not really going to wait for it to finish or review because it's just a demo. but I am going to merge it now to our live environment. So our change is now merged to our production branch. All I need to do to deploy it to our live environment is to run that pull method again. And again, this is going to see what changed and load it into our namespace. Now I can go back to VS Code and see our class has been changed with the size as we expected. All right, so in summary, we've used Git and Git source control, our open source project, to show a full development workflow, including some basic continuous integration. Something I want to stress is that Git source control is something that is in active development. We're very much working on it, and we love customer feedback. We're actively working on it this summer. We have weekly stakeholder meetings. If you're a customer who's using this, who wants to have some input on the shape of it going forward, please email me or Ben or Tim, and we can get you added to those stakeholder meetings. And with that, I'll hand it back over to Ben to conclude.
All right, thank you, Praveen. A pretty impressive demo, huh? And again, just to recap, he went from a complete, brownfield legacy application with no controls, with all the source in a namespace, through sideloading IPM, using the Git source control, creating a brand new project within GitHub, exporting it all, uploading it all, configuring it all, and then making a change to see it flow through with a new GitHub action in order to do the automated testing and then deploying it live. I think that's the most I've ever seen squished into a 15-minute demo. So, but it's also compelling as to the power of the tool. So let's go ahead and wrap up. With that, we've got a few minutes left for questions. So, yes.
So two questions. First, if the deploy, the server that the code is being deployed on,
Yes.
and the Git repository, remote repository are in the same network, could I force the Git repository, the remote one, to deploy onto the server without having to pull, for example, through a script or something?
Yeah, absolutely. That's something I forgot to mention. So that pull command I'm running in the terminal is something you could easily automate with a GitHub action. Basically, you want GitHub to be calling some webhook on your production server that sees something has changed and runs that pull command to automatically load.
The other question was, do you use the InterSystems integrated export and import function, so export ODL and UDL, I think it is, to transfer the data, or do you use it via like just replacing text? I'm asking because when you transfer source code between versions, for example, some commands might have different meanings or like be replaced with something else. Is there any translation happening there?
We're just using the normal export, the integrated export and import. Yep.
Okay, so that should translate if there were any changes in the text.
Yeah, it will translate, and also the other thing you can do is you can set a qualifier on the exporting system. If the exporting system's a newer version, you can set a qualifier to force it to use the export from the older version until all of your targets have been upgraded. So that's the way we handle upgrades for internal apps within InterSystems, is we will set the qualifier for anything that's pushing into source control until all stages have been upgraded, and then we remove the qualifier, and then future changes will be on that higher version setting. Great question.
When you're using the server-side folks, like in Praveen's demo, if you're using a deploy key, how do you differentiate between the different users making changes and pushing their changes? Wouldn't all those changes be under that one deploy key and one user?
Right, so under the Git commit history, the changes are associated on the Iris instance with a specific Iris user. And when that user is actually committing to the local repository, those commits will be under that user's attribution. But when you're pushing to the remote repository, that will all just be one user in the repository. Yep.
Yep.
You mentioned that Git source control is still being worked on. What kinds of, do you expect
And we'd forgotten to repeat the question. So I'll repeat the question and Praveen can answer that one. The question was, since we're actively working on it, are we expecting disruptions within the Git source control tool, or is it just going to be sort of minor incremental updates?
I wouldn't expect any disruptions with the Git source control tool. Remember, this is something that you're pulling from the package manager or GitHub and installing locally. So you're going to be pinning a specific version, and when you're ready to upgrade to the new version of Git source control, you would explicitly do that. And we'll, of course, try not to break anything.
And I'll also add to that, if you've seen any of the demonstrations for Health Connect Cloud, our cloud-based Health Connect offering this week, that's actually using the Git source control package with updates that our team is making. So we're obviously very careful not to make any breaking changes because our whole cloud infrastructure is kind of depending on that. Yeah.
So in some instances, people might have to do hot fixes in production live. How does conflict management on the deployed server look like?
So repeating the question, sometimes you have to do hot fixes directly within live. What do you do about conflict management?
That's a good question. We should make sure that our logic that's pulling changes on a deploy is respecting any sort of, like, if somebody has a change on the production server, because we'll automatically add that change to a queue of like checked out files. So somebody else won't be able to go in and edit that file. And I believe that our deployment logic will respect that. So it'll like fail with a message saying this file is checked out by a specific user, and it won't just overwrite your hotfix.
I'll also add to that the best practice that we use within our team is if there's a crisis that necessitates a hotfix in live, that crisis is not completed until we have taken that same change, applied it in our base environment, committed it through our normal change control and source control processes, and moved it all the way through to live. It is considered continuing to be a crisis until that point. And one of the things that we often do in order to really emphasize that is, especially if we're dealing with classes, say, that we have to apply the hotfix to, we'll often do the hotfix to like the compiled int file, because we know that that's temporary. We know that's not going to stay. Then we're not having to check something out. It's actually not considered source control, but it takes immediate effect, and then we can go back to base, make the change, commit it, push it all the way through, it redeploys the class, it blows away the old int file, replaces it with the former fix. So to just operationally make the bar for hotfixes to be very high. Well, first of all, if you get to the point in your CI/CD where a change should be very fast to go all the way through, right? So we're able to make changes that originate in dev and go through 2 peer reviews, all the testing, all the way to live in 5 minutes if we've got to make a trivial change. So we will actually take the extra 5 minutes to do it right if we can. But if it has to be a hotfix, that crisis does not conclude until the proper change control has actually flowed through. Great questions, by the way. Yeah, I can tell there's been a lot of experience and pain in this room. Yeah.
Is there any restrictions on health share version with using Git source control?
The question is, are there any restrictions on health share version with using Git source control?
Not that I'm aware of restrictions on health share version, but I'll look into that. We have Tim as the expert on that.
So the answer was, if it's iris-based, you're good. Another question.
Since you mentioned that int routines aren't in the source control, what is also in the ignore, like system-based things that might not be interesting? What can I expect in my repository under default settings? And could I take out those ignorings if I wanted, for example, to include int?
Sure. So the question was, I had mentioned earlier that we don't include int in our source control. Is that the default? How do you control that? And so first of all, the general rule of thumb is if you have something that is generated, you don't put the generated thing in source control. You put the thing that is doing the generation into source control. So in our case, we're not using int files because they're actually classes that we're compiling. A lot of sites are directly editing int files. That is their source, in which case those are actually included in the baseline export that Praveen demonstrated, and those would be considered to be in source control. So if it's exported to the file system and then you commit it as part of your repository, it's considered to be in source control and controlled by the source control hooks. Praveen, can you comment on the configurability of that?
Yeah, in Git source control specifically, we ignored generated items, and there's not currently a way to configure that. If you'd like to make a GitHub issue to request that, absolutely feel free to.
Great. Other questions? Yeah.
Because it is server code control, I'm assuming there is no way for different developers to create different branches and make code changes for different versions at the same time.
So the question is, since it is server-side source control based, is there any way to allow different developers to make different branches within Git and work on those different branches at the same time?
Yeah, so I think what's relevant here is that it's a shared server-side development environment, and there has to be, in that case, a single source of truth for the code, a single Git repository, and that repository can only be on one branch at a time. So that's kind of why we're committing all of our changes just to main rather than creating feature branches, which might be a more common workflow.
Now, that being said, as we mentioned earlier, actually, I think we mentioned in a different session, source control hooks within Iris, server-side source control hooks are actually tied to a specific namespace. So that means if you have the ability in your shared server to make it a different namespace for developers, maybe that have more experimental projects or whatever, you could actually create a different branch to populate and tie the hooks in that namespace to the feature branch. But the main shared environment that multiple developers are hitting, that is going to be against your main. And the UI does have the ability to change the branch that is being looked at and whatnot, correct?
Yep, absolutely. I showed that, switching from main to prod. Yep.
And the check-in process or committing the code, that's through the web UI. Is there a way to do that directly from VS Code?
So the check-in process I showed is through the web UI, but there is also a way to do that through VS Code, through the source control menus. In VS Code Studio, the system management portal.
Yeah, VS Code with the InterSystems plugin actually respects all of the server-side source control hooks, including the menu generation and the menu actions. So that's why you could take existing server-side source control hooks that Studio respects. You know, in Studio it'll show up as a new menu or whatever, and all of those are exposed within VS Code so that you can trigger commands that way. Other questions? Obviously, this has been riveting because you guys stayed 2 minutes longer than the scheduled session. So we thank you for your attention and for your questions. Feel free to come and ask if you have any more. Thank you.
Yeah, thank you very much.